Good morning, everyone. I am glad to have the opportunity to present my research in the Soil and Water Conservation Society. My name is Rahmatullah Hashimi. I am from Afghanistan and a third-year PhD student at Tokyo University of Agriculture and Technology in Japan. I would like to present my research regarding long-term no-tillage and Rye cover crop system improve soil water retention by increasing soil organic carbon in Ando Kanto, Japan. Introduction. As we know, the Green Revolution, which occurred in the mid-20th century, marked a significant period of agricultural transformation with adaptation of modern farming practices. These practices, including the utilization of extensive tillage, high-yielding crop variety, synthetic fertilizer, and pesticide. As a result, food production was increased, but it also had a negative effect on the environment. Intensive tillage system, excessive use of chemical input, and deforestation lead to increased soil erosion and soil degradation, resulting in the release of carbon stored in the soil into the atmosphere as a carbon dioxide. To address these challenges, organic farming emerged as a good solution by avoiding chemical input. However, the tillage system used in organic farming for weed control and seed bed preparation has been found to decrease soil carbon amount. Recent and fast study indicated that organic farming practices conducted without the utilization of cover crop and plant residue can lead to a 40% reduction in soil organic carbon. Another study emphasized that inappropriate organic farming practices such as excessive tillage and lack of cover crop rotation also contribute to decline in soil organic carbon. These findings suggest to enhance soil carbon level in organic farming, it is crucial to carefully assess the balance between annual carbon input and output. Therefore, an alternative approach is required for organic farming to effectively increase soil carbon sequestration and improve soil structure stability. Therefore, our research objectives are to assess the impact of long-term no-tillage and cover crop system on soil organic carbon content, soil carbon sequestration, soil aggregation, soil bulk density, soil water retention, and finally, to analyze the direct and indirect effect of the soil variable on soil field capacity and plant available water content. Material and method. The study field design was established in 2022 using a randomized split plot design with 4 replication at Ibaraki University. In this research, 2 tillage systems, including no tillage and mold flow, were compared along with 2 winter cover crop treatment, Rye and fallow. The mold flowing tillage was done twice a year before the summer crop and winter cover crop. Rye cover crop was moved by a flare mower in both NT and MP. In the NT plot, the residue of Rye cover crop remain on the soil surface while incorporated into the soil through mold flowing in MP plot. The experimental site has a humid subtropical climate, which was suitable for double crop rotation with main crop in summer and cover crop in the winter. The annual temperature of this site was approximately 15.6 Celsius, and it received an annual rainfall 1,390 millimeter in 2021. The soil type used for this study was volcanic ash andosol soil. Soil sampling and lab measurement. In December 2021, we collected 2 types of soil sample: core sample to measure soil organic carbon, active carbon, and water stable aggregate, and ring sample to assess soil water retention. Soil sample were cut with a sharp knife into the 5 different layers, as you can see in the photo. Soil aggregate were measured using the wet sieving method. Five different size: 4 milli, 2 milli, 1 milli, and 0.5 milli and 0.25 millimeter respectively. The sieve were placed in water for 30 minutes and then were placed in the clean water and vertically shaken 60 times at a rate of 1 shake per second, while total carbon and total nitrogen were measured by CN analyzer. Soil water retention was measured through the pressure plate method, and active carbon was measured by the spectrophotometer machine. Result and discussion. Our results show that no-tillage significantly increased soil carbon in the surface layer, while mold plowing increased carbon content in the below 10 to 20 centimeter due to the incorporation of plant residue by tillage system into 0 to 30 centimeter layer. The cover crop effect was also observed only in 2.5 to 5 centimeter layer. Overall, these results indicated that adaptation of no-tillage system in organic farming can have significant benefit for the soil by enhancing soil carbon level in the topsoil. The use of winter cover crop can further increase soil carbon under no-tillage condition by reducing mineralization rate. These findings have important implication for sustainable soil management and carbon sequestration in volcanic ash andosol soil. Soil active carbon was similar like soil total carbon. No-tillage show the high active carbon in the surface layer, while MP show in the below 10 centimeter layer. These active carbon is also very important for the to make the soil aggregation, especially in the no-tillage system. Soil carbon sequestration. Our data show that no-tillage significantly increased soil carbon accumulation at various soil depth ranging from 0 to 15 centimeter. For example, 0 to 10 centimeter depth, NT increased soil organic accumulation by 17% as compared to MP. While these differences were more impressive at 0 to 2.5 centimeter and 0 to 5 centimeter, which were 36 and 25% respectively. While Ray cover crop also show some improvement in the soil organic carbon accumulation, but the differences were not statistically significant. Regarding soil bulk density and water content, no-tillage due to its retention of plant residue and reduced soil disturbance resulted in lower soil bulk density in the surface layer, but higher bulk density in 10 to 15 centimeter layer, while MP had higher bulk density in the surface layer as compared to the sublayer. Both tillage and cover crop significantly influence soil water content across all depth, with no-tillage and Ray cover crop showing the highest moisture content and gradually decreasing with the soil depth. In anti-crop residue retention improves soil structure, reduce evaporation, and thus increase soil water content. Soil carbon, bulk density, and water content correlation. Our data show that SOC and bulk density have a negative significant correlation, while soil organic carbon and water content have positive correlation. We concluded that no-tillage improves soil organic carbon and soil structure to enhance soil water content in the soil. Water stable aggregate in mean weight diameter. No-tillage significantly increased 4 milli and 2 milli aggregate size, while mold plowing increased smaller soil aggregate. In no-tillage, plant residue release cementing agents such as glomalin protein in plant root, which combine soil microaggregate and promote macroaggregation. Mechanical disturbance and plowing pressure during mold plowing cause the breakdown of soil aggregate, resulting in increase in the microaggregate. Therefore, the mean weight diameter also significantly increased in all depth in no-tillage as compared to mold plowing system. Aggregate associated carbon. Our results show that no-tillage significantly increased aggregate associated carbon in 0 to 10 centimeter layer in all aggregate size class, while mold plowing increased below 10 centimeter soil depth. In NT 0 to 2.5 and 2.5 to 5 centimeter soil depth, 4 milli aggregate size had higher average carbon content compared to the smaller aggregate. Ray cover crop also significantly increased carbon content in 1 millimeter aggregate size in both tillage system. soil carbon accumulation in virus aggregate size. In NT, 4 milli in 2 milli aggregate size store high soil organic carbon, while CT store in 0.2 milli aggregate and 0 to 2 by aggregate size. The strong physical structure of macro aggregate can help to prevent the loss of soil organic carbon to atmosphere, as well as reduce the vulnerability of soil carbon to oxidation and decomposition. Soil water retention, the result indicated that the tillage system had significant impact on soil water retention. No tillage show an increase in soil water retention at field capacity compared to the mold flow plot. These results suggested that no tillage may be more effective method for enhancing soil water retention and supporting plant growth in drought condition. We also calculated the plant total easily water content, V minus soil moisture from field capacity and permanent wilting point to calculate the plant total easily water content. And the results show that in all depth, NT significantly increased volumetric water content at field capacity as compared to the mold flow. For example, 0 to 10 centimeter depth, NT enhanced 58.9 ton water per 1 hectare at field capacity level and 16.1 ton per 1 hectare total easily water content, more than MP. We concluded that NT with recover cropping system increased field capacity and easily plant available water content and decrease the risk of drought under climate condition. Path analysis demonstrated that soil organic carbon had direct positive correlation with mean weight diameter and total plant available water content. Mean weight diameter was significantly correlated with field capacity, and these results suggested that the combination of soil organic carbon accumulation and mean weight diameter improvement enhanced water retention for the crop growth in no-tillage system. In conclusion, in undersoil soil, the no-tillage approach show better result compared to the mold flow system. The NT system lead the improvement in soil water retention, in soil organic carbon content, formation of soil macro aggregate, and overall soil stability. These results suggest that adaptation of no-tillage method in organic farming would potentially help to recover the loss of soil organic carbon and enhance soil stability that often occur due to the continuous mold flow system. Using cover crop like ray cover crop increase aggregate associated carbon in both no-tillage and MP system. This change is expected to further both soil organic carbon storage and enhance soil structure stability. So this is all from my side. Thank you so much for your attention.